Hello, welcome to this tutorial on protocol buffers. According to Google, protocol buffers are language neutral, platform neutral, extensible mechanism for serializing structured data. Now, there are some important keywords in this definition here. One is this idea of it being language neutral. It simply means you define your message irrespective of your language, and that message is compiled using the protocol buffer compiler to your language, to your any programming languages of your choice. Then, second keyword here that I like to talk about is this structured that they have here. Structured actually means, so if you have been building API with JSON and XML, you notice that we don't necessarily have to define we don't define the structure of the data ahead. Though in our programming languages, we have the classes, we have the DTO or whatever that, however you have structured your data, that becomes the JSON or XML that we send out to the user. But here, you have to define the messages, which becomes a protocol that you are going to use. So this idea of using strongly typed mechanism for your messages makes it really, really powerful. As you will soon realize, it's very efficient. So, for example, if you write the same message, if I like say this person object that we have here, if you fill in this person object, like fill in the name, the ID, and email address, you write it out as JSON, and then you write the same data out as protocol buffer, you notice that the protocol buffer version will be way, way more smaller than the JSON version. So basically, if you ask me why protocol buffer, I would say it's highly efficient both in terms of the size of encoded messages and the speed of encoding / decoding. The binary format ensures that the message size is much smaller compared to formats like XML or JSON. Since it's a binary encoding system, for real, it's way more efficient. Now, before we start the tutorial, I also would like to mention that I'll be using the Go programming language for this tutorial. Go also support binary encoding, but the downside to this is only your project would understand how you have encoded your data. But the protocol buffers that we have, protocol buffers actually is a standard. That means other programming languages can understand your messages. So this is a big win for protocol buffer. But then there are some, there are some downsides to protocol buffer itself, that no perfect technology, which I'm going to show you in the tutorial. So let's get straight into it. Intentionally, I decided not to mix up this tutorial with any RPC or any network programming project because it gets confusing. I want you to learn it as a messaging system, then you can use it with any network application that you are building. So let's get started. This is just an empty folder. It's nothing inside, not even Go module. So I'm just going to create a place called Proto B, right? And then this is where I'm going to keep all my messages, though we are going to have just one file in this tutorial. Contact.proto. Now, you see, I have the contact.proto. We have two versions. There is a version 2 and version 3. If you are just starting out, trust me, you just want to go with the version 3. You don't even need to think about version 2, right? So you come here, you take the syntax, and you define your message. Now, the message I'm going to use for this tutorial is coming directly from here, which is this person object that they have here. So we can take this out, then I'll explain it. It's just a bunch of text. It doesn't make sense typing it all over again, right? So let's take out things from here. Now, what do we have here? We have different data types. First thing you notice is the fact that we have sort of nested messages defined. So I think the simplest way to understand it, you can think about this as objects, right? So we have the person object, and then we have an address book object. Then you also have a phone type, right? And in the object, we have fields. This is how I like to think about them. If you want like a very formal way of thinking about them, sure, you can check out the documentation. But for me, it's easier this way. Now, what do we have here? We have an address book that contains people. All right. So let's start with the address book. The address book is a container that contains people. As you see, people is of type person, which is also repeated. That means it's an array, right? Now, how this array is going to be represented depends on the programming language that you compile for. Then, if you go to the person structure, which is this one, we have different fields. String is name, ID, email. Now, you might be wondering, why do we have these numbers 1, 2, 3? Here as well, we have 1. Each of the fields are numbered. And this is real for me. This is the most important thing about protocol buffers. The numbering is really important. The first time I looked at it, I was like, this numbering thing can get really, really confusing, especially if you have very large message. But trust me, this is the design. The numbering, and you can't, when I'm going to show you something later, the significance of you trying to change the numbering, it has real consequences. So you have to number them, like starting from like 1 to, and you can check like the limitations, the constraint of the number. So just number your fields. Then if you notice, we have embedded message here. So person, so it's like person.phone number, right? So we have a phone number type. Then in the phone number type, we have number and then a phone type. Phone type is an enum. The enum, the most important thing in the enum is the fact that this 0 is important because this is the default type. So your enum should always have a default type. It's really important. All right. Then after that, also you remember we saw repeated here, and there's also repeated here. So anywhere you see repeated is an array. That means it simply means this person can have multiple phone numbers. And the field name is phone. So this is the type, this is the field name, and this is sort of the index. All right. Then here you have something that is a little bit weird, like google.protobuf.timestamp. This is sort of an external message that we are including so it is called last updated, which is indexed as 5. But where is this coming from? We can include it. So if you want, you can say, let's go back to the page, look at it. Let's start with this. So we can bring this one here. So we just included that. You see, the error has gone away. Now, because we want to use this for Go project, we need to define something for Go. Option, Go underscore package. So what is the Go package we want to use? At the moment, we don't have the Go modules set up yet. So let's do that. So I'll say Go mod init. I'm going to do it to my GitHub this way. Protobuf example, something like this. This becomes my, actually done. All right. So let's copy that. And then what I'm going to do, I'm going to say /contacts. So simply means I will be having a contact folder here as my package. All right. We need an equal sign here. We also need a semicolon here. Now, you need to also specify a package here for your, it's basically like idea of namespacing, right, for your message. So this is the whole structure. Let me close this down. This is the whole structure for a message, and this is what all we need to start using it. So when you have this defined, what next? This, if you want, you can add different options for Python, for Java, for different programming languages, right? But because we are using it from Go, I only have this one here. Now we have defined our message. At the moment, it's sort of useless, but we need to compile it to our programming language structure, which is in this case Go. So what do we need? We need the compiler, which I have installed. The reason why I skip the installation part is because installation is different for all the different programming languages. So for you, you can just come to the documentation and then install for your own. But on my system, I have the Proto C compiler. So you see, so I have it installed already. But what I want to do now, instead of typing the command, is a little bit long. Instead of typing it here, I'm going to create a makefile. If you don't like makefile, I understand, and you don't have to put a do the makefile part. Is you can just paste the command. It's a single command, and but since I'm going to run it multiple times, I just want to put it here, right? The command is, let me put a gen proto target here, and I'll call the proto C. All right, this is the compiler that I installed on my system already. It has some options which you can see on the documentation, but let's continue. Proto underscore path. So where are our proto files? They are right here, right? So the folder name is proto B, right? Then where do we want to put our output? The compiled files, the Go files. Already we say we are going to have them here. That is why we specify this place as a package, right? So we are going to say Go underscore out will be contact. Then we need some options. So which is, because the folder is relative, we'll do Go opt. This is not that important, but yeah, I'm going to specify it. Equal to path equal to source underscore relative. Now, if you are doing gRPC and a whole other like RPC options here that you can specify, but hey, we just focusing on this protocol buffer right now. Then we specify that we want to do that. Here you can specify a single file, let's say this contact, but I want everything in case you want to have multiple files. So everything that has the .proto, we want to compile it. If there are no mistakes, we should be able to take this command like this and run it. So I can just do make. You can do make or just copy the command and paste. It will work as well. All right, I don't see any error, so it looks like it works. So we open here, and this is our generated Go file. Now, when you open the file, it looks really ugly. So you don't even want to come here. Don't want to come here. The next thing for Go, the next thing you will need to do, if you are doing Java, this next step would be a little bit different. But for Go, if you notice, we have different packages that have been included. So we need to run go mod tidy. And this will go ahead and download all the modules for us. And I think that has been done successfully, right? Let me run it one more time. Yeah, it looks like it has been done. All right. So next step is to test it. How do we test it? So let's create a main.go. All right. And then let's start testing it. All right. So let's create one person. So I'm going to say P1. Remember, the person is in the contacts. Let's look for contacts. Contacts. All right. It doesn't seem like this was properly synced. Let's do it again. Let me look at just a minute. Let's look at this place. Something, it didn't work. Go mod tidy. Okay, no problems. We know how to import it, so let's go ahead and do it. Let's see what happens. Import slash contact, and we can say p1 equal to contact dot person. So for now, I'm just going to say log print ln for this p1. Let me run go mode. Okay, let's do it again and see. And it's working, but our ID is a little bit mixed up. So we don't see anything here, but there are no errors. So I'm going to continue. I don't know. Let me check the ID if there is anything I can module, enable Go module integration. I think that's the thing that didn't happen. All right. It looked like our ID finally worked. So great. So we have let's construct the person. So name. We can put the names here, but how about let me bring something. Let me bring one library. This fake it library. This has nothing to do with the tutorial, but if you are looking for a way to generate fake data quickly, you can take a look at it, and I can import it here now. Instead of me typing email addresses, I'm just going to say faker, and then I can do faker.name. Simple. This one has nothing to do with Protocol Buffer. Trust me, it's because I don't want to type email address and everything. So what do we have? If you go to the person structure, you see we have name, ID, email, phones, and everything like that. So let's look at it. So name, the ID can be is int32 we have. So faker.int32. And you also can reference this. So name, ID, email, faker.email, phones. You remember I told you that phone is, look at the structure of phone. So it's a pointer, a slice of pointers. All right, so of type, person phone number. It's tricky, but we can do this. So contact. So is this one, like this. And I think we should be able to, so the phone has number, and then I faker dot phone, phone type. I think, is it type or phone type? Let's look at the type quickly. Type. All right, type. And it's contact. So this is the enum now. Contact. Let's give it home. So phone type, home. All right. What else do we have here in the person message? So we have this phone last updated. Last updated is last updated. What type is it? It's a timestamp. All right. Would time.now work? Time.man doesn't work, so we can does proto. Let me take a look at it one more time. What is this? Let's look at the structure. So this is what we have. I'm going to import it. And it's a pointer to, so let's take the pointer dot. So this is the time. Maybe we take this guy out. Great. We got it. What else? So we have that. We have the phone number. and phone number. Okay, it's interesting, right? We have so we have the phones here, and that's it. All right, so that's good. That's good. Next is now that we have one person, how about the address book? So let's create our address book. So our address book will be a pointer to address book like this. And remember, we have people inside, which I for sure know that will be a pointer to contact dot person slides like this. And of course, we can bring this pointer to P1 here, and this should work. All right, so this is our address book. Let me close this guy down. This is our address book, and this is the person. So we have this person, just one person in the address book, and we can add, maybe we should add one more, P2. And since we are using fake data, we don't even need to change anything, you know. It's interesting because if you want, we just do a loop, right? And we can have all the data we need, P2. All right, so we have P1, P2. Now, what else? What can we do with this? So we have the structure. Sure, we can time to, this is the serialization phase is what we need to do next, which is simple. Let's say this is out is bytes. So we say proto dot marshal and we give it the message, which is, in this case, is the address book. Let me check for error. If error is not needed, we just filter. Here, you have the bytes back. And when you have bytes in Go, you can do anything. Send this to a network, write it to a file, which we are going to do anyway. Do anything you want to do with it. So let's write it to a file. Easy. So we can say error is equal to os.write file. In short, maybe we can ignore the error for this one since we know what we are doing. Hopefully, address.db. And what are we writing? Just the bytes. And I can say 0644. That's the mode. All right. Let's run the program. At this point, we should have the file written. So let's run the program. Go run. Great, no errors. And this is our address book. So let me do ls. This is our address book. If I cut, let me try to show you the content of the file. It looks going to look weird because it's binary encoding. Look at. Beautiful, right? This is what we want. Welcome to Protobuf. Now that we have the data stored somewhere, I'm going to comment out this code. We don't need this code anymore. So let's imagine this data that we have stored somewhere is coming in over the network, right? And we are going to grab it from an IO reader or something, right? So let's read it in. I'm going to say in data. Let's just call it data. Error is os.read file. And then address.db. You don't even need to do much here. Just check for the error. Now that we have the data is bytes. You see, it's just we have the bytes back. What do we want to do with it? Let's turn it back into the structure. So let's go here. We create something like this, right? And we are going to turn it back into the structure. It's really straightforward. So if the proto has a marshal, so if you remember, we marshaled earlier, so we are going to unmarshal now. So it takes the byte and the message. So I'm going to check for error. So we are going to take the byte and then the address book. Remember, it has to be a pointer. I'm passing it directly here. If I did it like this, I would have had to do it this way. But since we have a pointer here, we have to pass it like this. And then we check for error. At this point, if there are no errors, we have the full data, the same thing that we have here is now populated in this address book. So this is when you read it from the network or from disk or from anywhere, and you now turn it into the structure. It's like or marshalling JSON into your structure, and we can do anything we want to do with it. So let's do it. Let's go for, I'll skip the index, person in address book dot people, right? The reason why you're seeing me typing like this because of Python. I've been doing a lot of Python projects, so yeah. So we go here, font.println. We can now print the person.name. Let me start with the ID actually, because I want to show you something really important. Person.email. And for the person.phone, since it's an array, and we know we just added one, so I'm just going to number. There's only one phone. All right. So time to run the code again. So go run. And you see we have both. So this is the ID. It doesn't matter even if it's negative. We didn't say unsigned int, we just say int. So here we go. We have our data back, really, really nice. So in a nutshell, this is protocol buffer. Let me do a quick recap. We defined our message. You can have many, many, many files here, many, many complicated structure. But the concept, the message definition should be really simple. It should be modularized. That means, look at how we have defined the phone type. It can be, if you know you are going to use this in several places, it can be a dedicated file that you include and all that, right? So we have our message defined and we compile it down. I think the most difficult step is this compilation phase. As if you have the compiler installed for your own programming language, that's it. So the rest is really just do something, compile, and then you create your structure. You can write it to network or write it to a file, read it back, do anything you want to do with it. Okay, now if you go here, if you go to this place, there are like best practices. Honestly, before you use protocol buffer in production, you should read this document end to end. I want to show you something like some nasty behavior because of how binary encoding work. So let's say we go here. For some reasons, I'm just going to flip this over. The order doesn't matter, but I'm going to change the number here to 2 and this one to 3. Email was 3. ID was 2, but I just flipped their number. Now I'm going to run make to regenerate my, I'm going to regenerate my protocol buffer. So my messages has been recompiled, right? So I have a new, this document has changed a little bit. It doesn't look much different. Do you see that it's the same thing? In short, there are no errors. If I go back here, if I open this up, there will be no error. Where is the I need to take out the last comments that I put. Okay. Yeah, this one. All right. You see, everything looks, this is no big deal. We can just name it 2 and this, right? So you see, no errors. It looks the same. It's fine, but something significantly has changed in our data structure. What I'm going to do, I'm going to disable this back, right? I'm going to disable it back. Now, this is the old code. Maybe I should, where are we? We're reading here. Oh, think here. Yeah. Okay. Yeah, address to that. So we are reading from the file. Remember, the encoding was different. Now we changed the encoding, recompiled, but we still have the data. This is really important, so please pay attention. Even if this is the only thing you have watched today, trust me, you're going to probably thank me for this. Now, when I go, let's run the code. We're just going to run the code, nothing. We're just going to read it from file, the same thing. If not changed anything, that's except from the recompile. Now you see, ID has disappeared. Email is no longer here. Now we have corrupted data. And this is really important because of that single little changes that we've made. The structure of our data has changed. What we have, the data that we have saved is no longer being represented as it should. So this is why whenever you have your data, when you compile your message and you have used that message to write some data and stored it somewhere, trust me, you don't want to you don't want to change the field numbers. You don't want to change them. In short, ideally, you shouldn't reuse them. Even, for instance, even if I delete email out, you shouldn't reuse them. So, like I said, please take some time to read our best practices. I'm going to recompile it now. And then I'll run the program again. And you see, it's working again. So there's a lot of little things here and there that you should be aware of. Message size, naming convention, things that are really, really important before you can start using them. So thank you so much. If you like this tutorial, please subscribe to my channel. I have more coming. I'm doing a lot of building a lot of tutorials on network programming. So next step is we're going to use this gRPC to start building microservices on this channel. If you love Abba Joseph, you love what I'm doing, please support me by subscribing to my channel. Share my videos on your social media to support the channel. Thank you.